Good morning. This lesson is for my Trig-Precalc class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this. I'll tell it how I title it in the title. But what I am sure of are 3 goals for the day. Our first goal is going to be to review exponent rules. We're only going to look at a couple. Our second goal is going to be to solve simple exponent equations. And our third goal is going to be finding inverses and verifying. So let's go ahead and jump right into this first goal. Now, I want to remind you, if you're watching this lesson because you weren't here, please, if I write it, you write it. So right now you should have all this written at the top of your paper, and you know what the goals are. And again, if I write it, you write it, so everything that I have here, you should have written. So jumping into our first goal, I'm going to talk about the most basic exponent rule, which x to the 4th power, or x to the power 4, is x times itself 4 times. So whenever I have it written like this, that means that I have that. And that's what we're going to start off with to create our second exponent rule, because that's our most basic exponent rule, is that we can expand what we have. All right. So I'd like to use our basic exponent rule, or the definition of an exponent, to show you what this equals. And so we have 2 exponents, and I'm going to work my way from the outside in. So I'm going to start off with this power 2. And that power 2 means that I have 2 sets of parentheses. 2 parentheses multiplying to itself. And inside each parenthesis, I have 3 x's multiplying to itself. That. So if I count this up and rewrite it using an exponent, that means that x to the power 3 raised to the 2nd power is x to the power 1, 2, 3, 4, 5, 6, x to the power 6. So our exponent rule that comes from, this is actually the definition, not the most basic exponent rule, it's a definition of exponents. But the rule that we create using that, we can generalize and say the following: a to the power m raised to the n power must be equal to a to the power m times n. So whenever I have an exponent inside a parenthesis with another exponent on the outside, that means that I'm multiplying my exponents. Okay. Let's move on to our second exponent rule. This is really not in any particular order, but this is something we do need to understand. The nth root is equal to that value to the 1 over n power. Now, we deal with square roots. Square roots have a hidden nth root, and it has a hidden nth root of 2. And that actually, following this exponent rule, means that we get to parentheses to the 1/2 power. I would like to calculate now the value of a square root using the exponent rule for square roots. So I know that 9 is the same as 3 squared. I'm going to ask you to find the square root of 9, but I'm not going to just say square root of 9 is 3. I'm going to show you how to use the exponents to accomplish that, because we want to be familiar with how the exponent rules are used. So if I ask you for the square root of 9, that'll be equal to the square root of 3 squared. So we're here. We're going to jump to here now, which means that I get parentheses 3 squared to the power 1/2. We now have this rule, so I can now multiply my exponents, which gets me to 3 squared times 1/2. My 1/2 and 2 cancel out. That's equal to 3 to the 1st power, which is just equal to 3. So this would be us calculating the square root of 9 using exponents, which is, we want to make sure that we're familiar with exponents. All right, so what I'm going to do is check off the first goal, and we're going to talk about, when I come back, how to solve simple exponent equations using rules of exponents. So let me clean all this up, set up the next goal, and I'll be back. I'm back. So let's go ahead and jump into the second goal, which is to solve simple exponent equations. And we're going to use our 2 rules that we have, right? But let's go ahead and let me explain what the second goal is about and how we're going to get there. We can raise both sides of an equation to the same power. So here's an example. If we have the equation A equals B, where A is a side and B is a side, we can raise both sides to the power C and get side A to the power C equaling to side B to the power C. And in actuality, I should add parentheses around side A and parentheses around side B. All right, so I like to solve for x using our exponent rules. Remember, we have two exponent rules that we have. A to the power m to the n power is a to the power m times n. And the second rule is the nth root is equal to that number to the 1 over n power. So I'd like to do example 1. I'd like to solve for x. And we have to figure out how we're going to get rid of that exponent of 2. Well, let's see here. We actually don't need to do this. We can jump right into this because I can make a 2 turn into a 1 by exploiting that. And we're going to raise both sides of this equation to the power 1/2. So x squared to the power 1/2 is equal to 25 to the power 1/2. And remember, I want to see exponent rules, not just solving. We're practicing using the exponent rules. We'll know the answer is 5, but I want us to get comfortable using this. 25 is the same as 5 squared, and now I've created the first exponent rule on the left side of the equation and on the right side of the equation. So I get x to the power 2 times 1/2 is equal to 5 to the power 2 times 1/2, and on both sides the 2's cancel, so x will be equal to 5. You can put a plus minus, but right now that's not the big thing that I'm worried about. Again, it's solving using exponent rules. I have another example here. I have the square root of x is equal to 8. I want to use exponent rules. I got to start out with rule 2. Now, remember, I can put a 2 right here, which means that this becomes x to the 1/2 power. I'm exploiting this rule, so turning it into an exponent. X to the power 1/2 is equal to 8. We're going to raise both sides to the power of 2, and I'm just going to erase this just so we don't have an overwhelming amount of parentheses. So I have x to the power 1/2 to the second power is equal to 8 to the second power, which means I have x to the 1/2 times 2. My 2's cancel, and I have my x, and that's equal to 64. So again, I'm using my exponent rules. I have one more example that I'd like to do before we move on to the third goal here, and I'd like to solve the third root of x minus 4. Let's make that equal to a different number. Equal to 3. Okay, the third root of x minus 4 equal to 3. So I have the left side of the second rule, so I'm going to rewrite it. So I have the right side, so now I have x minus 4 to the power 1 over 3, and that's equal to 3. I'm going to raise both sides to the power 3, and I'm going to run out of room, so I'm going to combine it here a little bit. So you get raised to the power 3, and you get raised to the power 3. On my left side, my 3's will cancel out, and I'm left with x minus 4. 3 times 3 is 9, times another 3 is 27. Okay, I need to isolate that x, and that means that my solution to this equation is x is equal to 31. All right. So those are some examples of solving simple exponent equations using exponent rules. I'd like to come back and solve, or not solve, but I'd like to come back and show you the skills that we used here will allow us to find inverses and verify that. So let me clean all this up and I'll be back. I'm back for the last time, I promise. So let's go ahead and jump into our third goal, and that's finding inverses and verifying. And in order to do that, I need to use the steps I use for the simple, solving simple exponent equations. So let's go through our steps that we know how to find the inverse. Remember, the first thing is we're going to rewrite f of x as y. So I get y equals the square root of x plus 6. And now the next thing I'm going to do is I'm going to switch the x and the y. So I get x is equal to square root of y plus 6. And now we have to isolate the y. So that's what we have written on our cheat sheet as the steps to find the inverse. Now, remember we have exponent rules, which we're going to use. So here I have y plus 6 to the square root, which means that I have now x equals parentheses y plus 6 to the 1/2 power. I need to get rid of that 1/2 power, and I'm going to accomplish that by raising both sides to the power of 2, so I can cancel that out. That cancels. So now I'm left with x to the second power is equal to y plus 6. Let's bring this up. So I'm going to write it again. You don't have to write it twice. And remember, if I write it, you write it. Now I can isolate that y, so I subtract the 6 to both sides. And now I have x squared minus 6, that's equal to y. And once I isolate the y, I replace it with f inverse of y, and I'm going to switch sides of the equation here. So now I have f inverse of x, not f inverse of y, f inverse of x is equal to x squared minus 6. So now that I have the inverse, I'd like to verify that I have the inverse. Remember, the main idea of the first chapter in this class is we're going to get comfortable plugging in goofy things. So I want to plug this function into this function, and if they're inverse, they're going to cancel out, and I will be left with x. All right, but I want to use exponent rules. I want to see those steps shown. So I'm going to write my original function with empty parentheses. Everywhere I have an x, it's an empty parenthesis. And I'm going to plug this value into that side, saying I am plugging my inverse into the original, and I'm going to plug the right side into the right side of the original, and that is x squared minus 6. So now let's just focus on this side. So I can drop the parentheses, and now I have x squared minus 6. Oh, the original one was plus 6. Let me fix that. X squared minus 6 plus 6. My 6's cancel out. That's not a very good marker. It's going to be retired. And I'm left now with the square root of x squared. But the square root of x squared is going to be parentheses x squared to the 1/2 power. And if I follow my rule, that becomes x squared times 1/2. Those cancel out, and I'm left with x. So this shows me that I have inverses, because when I plug them in, I get the identity. Remember, inverses lead to identity. So how the finding the inverse problem is going to elevate a little bit in difficulty, but we'll see that it's really not too bad. We're using some pretty simple mathematical ideas here. So I'm going to go ahead and end the lesson here. I hope everyone's doing all right out there. Have a great day, everybody. Bye-bye.